So I want to do a little review over some questions on Chapter 5 exam that might be helpful for you to when you're reviewing for your final exam, or maybe answer some questions that you might have misunderstood during the exam. So this one here says the angle of an elevation to the top of the tower from point A on the ground is 11.5 degrees. From the point B, 39.4 feet closer to the tower, and the angle of elevation is 13.9 degrees. Wants to know what is the height of the tower? So first things first, we need to draw this out. So if I was to draw out my triangle, we're going to have, and my pitch was not very great. But my line was straight. Be this a little patient with me. Thank you. There we go. That looks a little better. Go straight. Oops, straight down. Oh, rough. One more shot at it. All right. So we're wanting to look for the height. We're going to call it Y. Excuse me. All right. Now let's label. I'm going to change the coloring up a little bit. We have this angle right here. Well, actually, let's finish labeling real quick. This is big A. This is big B. Now we have this angle right here, and it's 11.5 degrees. We're going to call this point beta, and this point gamma, and this one A. Let's finish writing out what we know. We got this angle right here, which is 13.9 degrees. And then this distance right here, 39.4. All right. So now let's solve. So the first thing we want to do is we need to figure out what beta is. So let's solve for that angle. I know I got 180 degrees minus this complementary angle right here, which is 13.9 degrees. And when we calculate that, we get 166.1 degrees. Okay, so now I'm going to write it in right here, 166.1 degrees. All right, now let's solve for gamma. Let's pick orange. So gamma is going to be the 180 degrees minus that 166.1 degrees minus the 11.5 degrees. And that gives me 2.4 degrees. So that goes right here. Okay, so now that I've done that, let's solve for side A. So let's go back to purple. So side A, I'm going to use the sine law. And I'm solving for sine, or for A. And we know what the sine of alpha is. So we're going to cross multiply it to undo that fraction. So I'm going to rewrite it as A is equal to C times sine of alpha divided by sine of gamma. Let's plug in. So C is going to be the 39.4. Sine of alpha is the 11.5 degrees, all divided by the sine of gamma, which is 2.4 degrees. And I'm going to come over here, and we're going to round to the nearest tenths. I got 187.6. Okay, so now the next step is to find the height. You know, so we could write that in if you wanted to for A right here. So let's find the height. To find the height, we're going to use the formula of sine of this angle, this angle right here. I'm calling it gamma for now, but you can call it the beta, the other side. I mean, the notation is not I mean, just be careful with the notation, okay? That's what I'm saying. So if I wrote beta here, it might be confusing because we got beta on the other side of the triangle. So it's y over a. I'm going to cross multiply because I'm solving for y. So I'm going to cross multiply the a. So I get y is equal to sine of the angle. And hang on, let me write this a little bit neater. Y is equal to a sine of the angle. And I'm going to plug in what I know. I got, for A, I got 187.6. That angle that was given there is 13.9 degrees. Then I type it in my calculator. 187.6 sine 13.9. Make sure you're in degrees mode when you're doing this. I get 45 feet is the height. And that was the answer. Okay, so let's move on to the next one. The next one says solve this triangle with these certain given parts. Well, if you notice, you're given all sides, no angles. So we're going to use the cosine law here. And I'm going to just pick the first one, which is a squared is equal to b squared plus c squared minus 2bc cosine of alpha. So remember on the cosine, on the cosine laws, if it's a equal, then it's alpha for the angle. If it's b equals beta for the angle. If it's c equals, then it's gamma for the angle. So whichever one you use, just make sure you set it up correctly. I am going to subtract because I'm solving for the angle, right? I know the sides, so let's subtract these sides from both sides. So I'm going to rewrite that. Let's rewrite it. So I got a squared minus b squared minus c squared is equal to negative 2bc cosine of alpha. I'm going to divide by the negative 2bc because it's multiplied to the cosine. So to undo it is division. I'm going to rewrite it where cosine's in front. All right. Now let's take the inverse of cosine. So I'm going to come over here. So I get alpha is equal to cosine inverse of a squared minus b squared minus c squared divided by negative 2bc. And I'm going to come in and plug it in here. Plug in what I know. So a is 23.7 squared minus b is 15.5 squared minus 16.4 squared, all divided by negative 2 times 15.5 times 16.4. And let's calculate that right quick. All right. Make sure you close your parentheses. Make sure you're in degrees mode to avoid errors. And I get 95.5 degrees, or excuse me, 95.9 degrees. Okay. So now let's take the law of sines So I'm gonna say sine of beta over B is equal to sine of alpha over A. And I'm gonna solve for that right quick. I'm gonna say, cross multiply the B. Now I got sine of beta is equal to B sine of alpha over A. And then we're going to take its inverse of the sine. Okay, take the inverse of the sine. All right. So let's go solve or plug in. Let's plug in first. We know what A is. A was 23.7. And B is 15.5. Sine of alpha, and which is 95.9 degrees. So beta becomes make sure you're in inverse. You use inverse for the sine, and you're in degrees. And I get 40.1 or 6 degrees. And then we could look at, let's scroll back up here. Solve the triangle. So we got alpha, we got beta. So now to find gamma, we're going to say 180 degrees minus the 95.9 degrees minus the 40.6 degrees. And now we'll know what gamma is, and then we'll have all parts of that triangle solved. And got 43.5 degrees. And that completes it. So we solved for alpha, beta, and gamma. Okay, let's move on to our next one then. Our next one says we have a force of 6 pounds and 16 pounds that act on an angle of 90 degrees. We're going to find the magnitude, the resistant of the resistant force, and we're going to find the angle of the resistance that makes with this first force. All right. So I'm going to draw my triangle out. Let me draw this just a little bit neater. So I'm going to make sure my triangle has that 90-degree angle. Oops. And I'm just determined not to draw a straight line down. There we go. It's a little crooked. Looks awful. I'm going to try one more time. Thank you for being patient with me. There we go. So, I spoke too soon. But anyways, okay. Hopefully y'all draw better than that. I've been working with these here. I could try the shapes right quick. Maybe that will give you a better looking triangle. So let's pick one. Ah, there's a 90-degree one. That's a little bit better. Yeah, that's a little bit better. All right. Now, let's call this the longest side here, U plus V, which is equal to W. I know that it's been called C equal to C, which is A plus B. However, in this section, they used U and V and W, so I was staying with that. Let's call this V and let's call this U. And then we have a force of 6 pounds, so we're going to call this one 6 and this one 16. So you all recognize the Pythagorean theorem is what's going on here. So we got W squared is equal to U squared plus V squared. U is 6. V is 16. So we got 36 plus 256, which is 292. So let's take the square root of both sides. So W is equal to 2 square root of 73, which is approximately 17.1 pounds. So that answers the magnitude of the resistant force. Okay, so that answers one part. The next part is, we notice that on this triangle, this is the hypotenuse side, this is going to be the adjacent, and this is going to be the opposite, which is also called y-x, right? So since we know the adjacent and opposite, let's use tangent. All right. Now let's solve for the angle by taking the inverse of tangent. And let's plug in what we know. Oops, don't forget the tangent, inverse. I gotta correct my notation right quick. So I have 16 over 6. I'm gonna plug it in my calculator. I get 69.4 degrees. That actually answers this last part, the angle of the resistance that it makes up on the first force. So there's my answer for that one. Okay. Let's solve for the next one. It says find the area of the triangle with the given parts. Okay, so we are given one angle and two sides. So let's use the sine law. So I got sine of alpha, because we know we're given alpha over A and we're given A, so that works out great. Sine of beta over B, we're given B. We don't know what beta is. So let's cross multiply that B. So now I got sine of, oops. Yeah, I'm gonna set it equal to that. I'm just gonna set it that way. Sine of beta is equal to B sine of alpha over A. And I'm gonna rewrite it, taking the inverse of sine because I want beta. And then next I will plug in what I know. Some of you may plugged in already, that's fine too. Okay, so B is 11.9 sine of alpha, which is 39.8 degrees, all divided by A, which is 13.6. Type it in our calculator, we get 34.1 degrees for our beta. Now let's find gamma. So I'm going to take 180 degrees minus my 39.8 degrees minus my 34.1 degrees. And I get 106.1 degrees. So the last part now, let's find the area. So I get A is equal to half of AB sine of gamma. And let's plug in. Well, I chose this one out of all the area formulas for this section because I know what A and B is. We were given A and B. We got 13.6 times 11.9 sine of 106.1 degrees. Let's plug that in our calculator. Okay, oops. Gotta make sure and close our parentheses, guys. keep from having error. And I get 77.7 is my area. So we answered all three parts. What was beta, what was gamma, and what is the area under the triangle. Okay, so now let's do the next one. The next one says find the smallest positive angle between the given parts. So you were asked question 1, what is A dot B? Well, y'all remember in this particular one, it said the notation of absolute value of V. Well, in our notes, we were talking about calling this one U and this one V, and call it A. If you wanted to call these both V, you could, and subscript it as VA, VB. The notation is important because it keeps you in order. However, as long as you know which part is what, that is fine. Okay, so, just make sure and just notate it correctly, okay? So if you choose to use a U for it, we're going to call this U1 and U2. We'll call this V1 and V2. So whenever we find the dot product of it, we're going to take U1 times V1 plus U2 times V2. So I got -6 times 1 plus 3 times 6, which A dot B is equal to 12. Okay, so that was the first question. The next one asked you to find the absolute value of A. So the magnitude of it. So that means I got to take the square root of A squared plus B squared. Well, you also know the notation of A comma B, which we know is X comma Y, right? We've talked about it being notated differently. We know what it is. A is the first coordinate in that order pair, and B is going to be the second. So now I got 36 plus 9, or 45. Yeah, 9, which is the square root of 45. I wanted to show this extra step. 45 is 9 times 5, so my answer is 3 square root of 5. Okay, that answered that question. Take the magnitude of B. We're going to do the same thing, but of the next order pair. So this order pair is A, this order pair is B. So I got 1 squared plus 6 squared. Clean my mess up right here. Okay, so 1 plus 36, 36 square root 37. So that's the magnitude of B. Now the last thing we want to do now is we want to find the cosine of the angle of the dot product of these two vectors divided by the magnitudes of the two vectors. So I'm going to rewrite it as alpha is equal to the cosine inverse of these. And let's plug in what we know. So we got 12 for the dot product. We got 3 square root of 5 times square root of 37. And we're going to type it in our calculator. And let's see what we get. Okay, we get 72.9 degrees. Okay, that should answer our questions. Make sure I didn't leave a problem out. If you have any questions about any of the test questions, just let me know.